Make sure the recording's going. Okay. So welcome to lab for week 4. I'm going to be walking through the less advanced homework and answering any and all questions. So let's start with downloading the homework 4 template. And we'll knit to start to see how it looks. Okay, cool. So I read all the instructions during class this week, so I don't think I'm going to be covering all of the instructions. Again, suffice to say, we're going to be replacing anything that says null with an answer and then knitting in between every answer to check if the answer was correct. One other thing is I will not be answering all of the short answer parts of this homework as part of the lab. But once you have all the numbers, I think it becomes clearer how to answer all of those questions. Okay, let's get started. First, we're going to be talking about coding with vectors. The first question asks, use the sequence function to create a vector of 10 numbers evenly spaced from 0 to 15. Okay. In order to do this, we'll say sequence, and I believe that it is 0, 15. But how are we going to evenly space them? If we ran this, that's 15 numbers. That's not 10 numbers evenly spaced. So one way we could check how to do this is to use the help function, question mark. So question mark sequence says, one argument we can provide is the desired length of the sequence. So we're going to be doing that wherever my cursor is. Here, we're going to say length dot out equals 10. And we can run this and then see these are 10 numbers. They're evenly spaced. And how did we do? Good job on vecnum. Question 2 says, use the, reading the name of this operator, integer or something. It's in the slides. Please forgive me. To create an integer vector of the numbers 11 through 20. I'm going to say 11 colon 20. So we can check what that looks like here. So this just increments by one number. Cool. Folks in the class, am I going too fast? Am I going too slow? We're good. Okay. For question number 3, we're going to use letters, which we used in lecture this past week, and the subset operator to create a vector of the last 10 capital letters. Okay. So just as a quick reminder, all caps letters is a pre-made vector in R. That's just all the capital letters in the English alphabet. So we can say letters subset 17 through 26, like this. Seems right, about right. Q, RS. That's the 17th letter. I don't know. But the thing to note with all of these questions is that they don't all require this kind of answer. We could have said, you know, sequence 1 to 10. Would that work? No. You would have also needed to do 17 to 26 here. So the answers that I'm showing you may not be the answers that you have on your screen, but as long as we're getting to the same place, that's okay. I tend to prefer how neat and clean this 17:26 is with the inside of our subset operator. Okay, question 4. So use letters and the subset operator to create a factor variable using the first 10 lowercase letters. I'm realizing now this should be in quotes so that folks know what I'm talking about. But lowercase letters was also covered in lecture. It's like uppercase letters, but it's lowercase. But we wanted to make a factor variable with the first 10 lowercase letters. Okay, so we have letters vector. We're going to use the subset operator. So we could say 1 to 10 the same way, but that won't make it a factor variable. We can just wrap this whole thing in the factor function. So a factor variable is one where there's an underlying numeric value to some sort of front-facing representation. So the example I tend to use is something like a Likert scale of how people are feeling. So like a fair is a 2 and so on. Okay, and now when we check out this vector fact, we see that it has these first 10 letters, but also it defines the levels, which are our sort of underlying representation. So it's saying that A is a 1, B is a 2. The order here is implying what the numbers underlying it mean. Okay, got that one. On number 5, we're going to use the concatenate or C combine function to combine our vector character and our vector factor into vector letter. Do not convert it to a factor. Okay. So we're going to use the C function. And then we can just say veccha, comma, vecfac. And let's check if it converted to factor. It did not. I'm realizing now I left this in from when R used to convert characters to factors if anything was combined with a factor. It no longer does that. So we can rest assured that it is a character vector. Cool, we got that one. Number 6, use the combine function and the subset operator to combine the first 4 elements of vec_num with the last 4 elements of vec_int to create vec_ni. Okay, so let's see. We want to use the concatenate function to combine the first 4 elements of vec_num. So we want to say vec_num subset 1 through 4, and then the last 4 elements of vec_int. So vec_int how say length vec_int is 10. So one way we could do this is just say 7 to 10. I'm sure there are very interesting ways to get work backwards from 10, but I think just checking how long it is and counting backwards in your head is fine. Cool. And then for number 7, the last one of our vector questions, use the rev or reverse function to reverse the order of vec fac. So we are going to say, have we had an example in class yet of using reverse? I don't know if we have. Let's see what it does. The help file says rev provides a reverse version of its argument. It's a generic function, the default method for vectors, and one for dendrograms. I'm not quite sure what a dendrogram is. Do y'all know a dendrogram? Excuse me? I'm sure, I think my mom has some of those in her garden. Okay. But it's going to reverse the order of our vectors. So let's see what does fac-vec look like. Yeah, the order of our vector has been flipped, but one thing to note is that the levels are the same direction. Okay, great. Next, before y'all turn on in this, be sure to answer these short answer questions in your own time. Things like if you use combine to combine vec int and vec fac, what class of vector did you get? Why? I kind of spoiled the answer to that one. Consider this code. What class of vector is this? You can check the class using the function, but you probably don't have to, knowing what we know about trues and falses. But let's move on to the coding with matrices set of questions. Okay. Number 1, use the matrix function to create a matrix with 10 rows and 4 columns filled with NAs. Okay. So we're going to say matrix. We're going to say our data is equal to NA. We're just going to hand it a bunch of NAs. And then we'll say the number of rows. So it takes this n row argument. It's going to be 10. And we can also say ncall. Yeah, ncall is equal to 4. So let's see what that looks like. A matrix with 10 rows and 4 columns, and they're all full of NAs. Welcome in. No worries, you can leave the light on. It's either way. Okay, so let's check that answer. Good job. The next one, number 2, says assign vec num to the first column of mat1 below. Also, do not edit this line, add code below it. So don't do that one. Do this one. So line 175, we're going to assign vec num to the first column of mat1. In order to get just the first column, we're going to need to use the subset operator over here on the other side of the assignment. And recall that if we want to affect just a column, we're going to say nothing, comma, and then the column that we want to specify. And the reason is because we're specifying or subsetting from matrices, the first argument will be rows, then a comma, then columns. But since we're not going to be affecting the rows, we're going to say nothing where rows is. So we could even add a space there just to like remind ourselves that we're saying we're not trying to specify a specific row. We want to just deal with this column. And we're going to assign vec num to it. So we already made the vec num vector earlier during our vector questions. That one wasn't found. So now when we look at mat 1, it's the same thing as our empty one we made earlier, but with the components of vec num here in this first column. Cool. On to question 3. Assign vec int to the second column of mat 2 below. Okay. So we're going to be doing a very similar procedure. And we want to subset to just our second column. And then we're going to assign vec int to that. And see what mat 2 looks like. Cool. Looks like it works there. Great. That was question 3. Let's move on to question 4. We're going to assign our character vector and our factor vector to the third and fourth columns of mat 3 using one assignment operator. Okay. So again, we're going to use this subset operator. We don't really care about the rows. Those are going to get populated with our vectors. But if we want to do specify our third and fourth columns, one thing we can use is the concatenate function. So we could say extract here. We're not caring about the rows, just the columns 3 and 4. And we're going to assign to that. Would we have to use concatenate again? No. I think that we could say cbind vec_cha and vec_back. Let's try it out. What's the worst that could happen? R sends me another error. I see 1,000 a day. Cool. So this algorithm says it's right, but let's see what it looks like. Mat 3 has like assigned the correct vectors that we're interested in, where we wanted them using the cbind function. But I was wondering whether or not concatenate would work here. I don't think it will. Maybe it will. I guess it does. I guess it recycles the like information because it has the right amount of rows. That's interesting. So either concatenate or cbind here. I kind of like am preferable to cbind here because I don't use cbind for anything but matrices. So I'm like making it very clear to myself if I'm coming back to this work, like this is a matrix and you're doing matrix things. On to question 5. Select the fourth row from mat 3 and assign it to the object row 4 as a vector. Okay. So we're going to select the fourth row. We're going to go to mat 3 and extract or subset the fourth row, comma, and then nothing. And I think this should work. We're going to check whether or not we got a vector. Actually, is it type of? No. Is dot vector row 4. Okay, so we got a vector doing this. Recall that like if we wanted it to keep its matrix shape, we would have to say comma again and then drop equals false. And now if we said is dot vector, row 4 would not be a vector. Okay. Number six asks, assign the element in the 6th row and 2nd column of mat 3 to value 6.2 as a numeric value. Okay, so let's say mat 3, we want to get the 6th row and the 2nd column, but I'm not sure this is going to be all that we need to do. We can check whether or not we have a numeric by saying is numeric, and then our vector, and it's not. So one thing that we could do to like force something to be numeric, the like typical computer nerd term is coerce. We can coerce this into being a numeric by saying as dot numeric and wrapping whatever we want to be a number. And this comes up from time to time. Say you have something that's like the number 23, but like as a character string. Maybe you actually want it as a number. If we say as dot numeric around this, now it'll come back as a number. We're doing the same thing here, but for whatever value we have of the 6th row and the 2nd column in matrix 3. Great. Let's see what that value was. 16. Okay, number 7 asks, use cbind to combine vecnum, vecint, veccha, and vecfac into matrix 4. Okay, I think this is pretty straightforward. We could just say cbind, and then the vectors in order. Vecnum, veccha, vecfac. Did it turn out okay? I think so. Interesting that they like keep these names. Okay. Seems to be going well. Question 8. Next, first transpose mat 4, then select only the first 4 columns and assign it to mat T. Okay, so the first thing that we want to do is transpose. And the transpose function, depending on the kind of like social scientist you are, might not come up a ton, but it's just a lowercase t for transpose. And so we're going to transpose mat 4. And then a curious thing, I think this always looks really goofy, but you can subset right from the outside of a function, and it will subset the thing that the function will make. So you'll recall during the lecture, we were talking about subsetting things right out of the summary function of like a linear regression. This is the same process. So we are going to subset the first 4 columns. Okay, so we're going to say nothing for the rows argument here. So I'm leaving this space here to remind myself, like, we're not saying anything there. And then we can say C 1:4 for like 1, 2, 3, 4. Okay, let's see what that looks like. Okay, so this is what answer we got using this strategy, but let's see what it looks like next to mat 4. So we can like highlight what happened. So we took the first 4 columns of the transpose of mat 4. So when we transpose mat 4, we flipped our columns and our rows, and then we took the first 4 columns. So it's like taking the first 4 rows here. So that's why it goes 0, 11, Q1. And then over here we have 0, 11, Q1 because we flipped our rows and columns. Cool. For question 9, use R-bind to add the rows from matrix 3 to this mat T first, then matrix 3 second, and assign this combination to mat big. Okay, so we're going to use R-bind to assign the rows from mat 3 to this. I feel like that wasn't great wording. My bad, y'all. So we're going to say mat T first, then mat 3. And I think that should do it. R-bind to add the rows from mat 3 to this. This meaning matrix T. I feel like I should have made this more clear. But let's see about this. Okay, that's what our matrix big is supposed to look like. And these questions, you can look at the names and the column names. I noted that just for a second earlier. On the lists. Okay, first question from lists. I feel like I'm going fast. Do we have any questions? Okay, we're hanging in there. Cool. The first question on the list section, use the list function to create a list that contains vecnum and row 4 and assign the names vecnum and row 4 to these 2 elements of list 1. Okay. Let's see. We're going to use the list function. And then we want the elements to be vecnum. But we want to name them that. So we're going to say vecnum in quotes. Vecnum equals, and then the actual vector that we're interested in. And this will be our first element. Then we'll say comma. I tend to hit enter after a comma for clarity. And then I'll say quotes row 4 is going to be equal to row 4. And this should do it. I'm just going to look at the structure of this list 1 we've just made. And something named vecnum has the contents of vecnum in it. Something named row 4 has the contents of row 4 in it. Cool. One thing I also tend to do is make sure that my equals are aligned like this by adding extra space after things that are not the same length. This is a convention that I think makes it easier to read when you come back to your code. And it's really useful when you do things like use the case when function when you want to like recategorize variables and things like that. Okay, question number 2. Use the $ or the extract operator to extract row 4 from list 1 and assign it to object row 4(2). Okay, so we have our list 1 object, and we're going to say $ to extract. And note that RStudio will like give you this little prompt like, hey, do you want vecnum or do you want row 4? So we can just hit down arrow and then enter to give us the row 4 element that we're interested in. And if you're ever wondering like, what things can I extract? That's one of the strengths of using like structure list one like this, is it will tell you by saying $, then the name of what you can extract. Okay. Cool. Question 3, create another list that contains value 62 and mat big. Okay. So we're going to use the list function. And then this one didn't ask us to name them, so I'm not going to. We can just say value 62 and mat big, and that should be enough. Well, it is best practice to like have columns or elements with names. This is sufficient for this. Okay, question number 4. Combine list 1 and list 2 together using the concatenate function and assign them to list 3. Okay, so we're going to combine list 1 and list 2 using concatenate to assign them to list 3. Okay. So I don't know. This one's like so straightforward as to be I'm like skeptical. Let's see. What's the structure of something like this? Okay. Gotcha. So it's like we have a list and then there's a list inside of here. Let's see if we did okay. Okay, that is what we're looking for. Number 5, use the unlist function to turn list 3 into a vector and then assign it to vector 3. Okay. So we're going to unlist list 3 and we're going to assign that to vector 3. So let's ask, what does unlist do? It flattens lists is what it says. Given a list structure called X, unlist simplifies it to produce a vector which contains all the atomic components which occur in X. Okay, atomic meaning just like one, like atomized. Cool. For number 6, use as.list with the function as.list to convert vector 3 into a list and then assign it to list big. Okay, so we're going to say as.list vector 3. And that should be it. I'm interested to know, how is the list actually that big? To do structure list big? Yeah, the answer is yeah. We could also say length vector 3, 71 elements. So we can also say that there's probably 71 elements in this. Yes, character. Great. Question 7. Now copy list 3 as list 4 and use the double subset operator, double square brackets, to assign list 3 as the last or the 5th element of list 4. That is, you should have a list object with 5 elements named list 4 that contains the same 4 elements as list 3 plus a 5th element that is all 4 elements of list 3 as one object. So the way we're going to do this is actually in 2 steps. The first thing we should do is copy list 3 to list 4. And one way we can do that is simply assign list 3 to list 4, and it will just copy it over. Okay. And then we're going to jump to a different line and say list 4, double square brackets, the 5th element, and we're going to assign to that also list 3. Okay, so if we run these, what we should have when we run structure, let's run structure list 3 first. We'll see that the elements of it, the vecnum from earlier, row 4, the value 6, 2, and then what was our last one? Mat big. So it's telling us the dimensions of mat big here. And then when we look, so we copied that over. And then when we look at the structure of list 4, it'll be the same thing, except for we have this first vecnum, row 4, value 6, 2, and mat big. But now our 5th element is also a list of 4 things, which are the same thing, vecnum, row 4, value 6, 2, and so on. So you can nest lists inside of lists, and they can get very big. Okay, so that's our list 4. Question number 8 says, select the 3rd element, that is the sub-element of the 5th element of list 4, and assign it to element 5, 3 using double square brackets to subset. Okay, so we're going to take from list 4 the 3rd element of the 5th element of list 4. So we're going to use double square brackets to get to our 5th element, and then we're going to chain together double subset operators to get the 3rd element of the list that's inside of list 4. I know, we're getting like really turtles all the way down here. I think that's how we're supposed to do this one. Let's find out. Okay. The computer's telling me I did a good job. So we're going to call it. Question 9. Lastly, repeat the previous assignment of the 3rd element of the 5th element, but extract the element as a list rather than a scalar using a single square brackets and assign it to list 5, 3. Okay, great. So then we can say list 4, we're going to again use that double square brackets to get to our 5th element, but we're only going to use 1 square brackets to get to the 3rd element of that sub list. But since we're only using 1 square brackets here instead of 2 like before, it will return to us a list. So now we can say structure element 5, 3. Okay, and it'll tell us it's a numeric, the number 16. But if we look at structure list 5, 3, it's a list of 1 with 1 element, and it's numeric, and it's the number 16. Do we have any questions about these list answers before I move on to data frames? Even if the question is just, can you scroll up real quick? Okay, are we cool to move on? Cool. Let's knit right quick before we move on. I feel like these are really fun questions to answer about lists, so have fun with that. but we're moving on to data frames. Okay, the first question of data frames, use data.frame to combine vec_num in the first column and vec_int in the second column into data frame 1. Okay, so we're going to say data.frame. This function, of course, makes data frames. And then we're going to say vec_num, comma, vec_int. I think that should be it. Let's find out. Okay. It's telling me that we did the right thing. One thing to note is that we didn't name anything. So if we look at df1, we didn't have to name these things because they are already named vectors, I suppose. Question number 2, use the $, the extract operator, to extract vec_num from data frame 1, and then reverse it with the reverse function and assign it as the vector vec_num2. Okay. So we are going to extract from data frame 1. So we're going to say df_1, $, and we're going to extract vec_num. But now we want to reverse it. Missy Elliott. So we can wrap the whole thing in reverse. And that should be fine. Let's see what it looks like. 2. Okay. Great. Question 3. Use the $, use the extract operator to add vec_num2 to data frame 2 as a new column with the name number vector. Okay. So what we're going to do is on the left-hand side of the assignment, we're going to write a $, and then we're going to write number vector here. So even though there isn't already an element called number vector, we can assign one to this data frame using the extract operator. So now we're going to go to the right-hand side of the assignment operator, and we're going to add vec_num2. I know that's kind of a weird operation. Are we cool? That's making sense why we did that and how it worked. Let's check it out. We can just say data frame 2, and we'll see that vec_num is here, but the rows 0, then 1.667, and then 3.33. And then recall we reverse that vector. So the 10th row here is 0, and then 9 is 1.667, and 8 is 3.333. Let's knit. Cool. Data frame 2 seems good. Question 4, combine data frame 2 with itself using rbind to create data frame 3. Okay, so rbind df2 with itself. So we can just say df2 again here to create data frame 3. I think that should be good. Cool. Question 5, create a new data frame called data frame 4 using data.frame function that contains the following named columns in order. Y, that contains 20 numbers evenly spaced from 31 to 125. X, that has 20 numbers between 0 and 10 generated using runif. Get help using the question mark runif. We'll do that later. And a color column that consists of 20 values sampled from the col_vec below using the sample function. Okay, so first thing we're going to do is run this line 325 so that we have access to callback. Next thing we're going to do is say data.frame in order to create a data frame. And the first column that they want in order is something called y. So in quotes, I'm going to say lowercase y is equal to, it's going to contain 20 numbers evenly spaced from 31 to 25. So earlier we did a question like this. So we used the sequence function, but now we're going to say sequence from 31 to 125. We're also going to use that length.out argument to equal 20 so that they're evenly spaced. So that's going to be our first column. Our second column is going to be x that has 20 numbers between 0 and 10 generated using runif. I know that it says runif and I say runif out loud, but it actually means random uniform, like the uniform distribution. So let's say question mark runif, and it's this one down here. And so these functions provide information about the uniform distribution on the interval from min to max. Doneif does the density, punif does the distribution function, qnif does the quantile function, and runif generates random deviates. So if you don't have a lot of stats background, then the use of like runif and run norm maybe doesn't seem terribly useful. But a uniform distribution just has the same amount of probability for anything that you give to it. So where are we? Here. So we're going to say comma, and I'm going to hit enter and say that x is equal to runif. Our min is going to be equal to 0. Our max will be equal to 10. And then our n will equal 20. I think that's one way we can do it. Yeah, that should be fine. And then we'll say comma and then enter. For our last one, which will be color, it's going to be equal to, we're going to sample from our callback that we created in line 325. If you're following at home, it didn't use the same amount of enters. It probably won't be 325, but I'm talking about this line here. So sample callback, and then comma, and I believe it's size. Yeah, size equals 20. And that's all we're going to say for the sample one. Yeah. So we're going to knit and see how this went. Okay, good job on data frame 4. One thing to note is right under data frame 4, it'll say this code should be used here to produce a plot with those colors that were sampled. So this code will produce that plot. Your plot, if you knit at home and didn't change the first block like I asked, will produce this exact same plot with these exact same colors because there's a set.seed earlier in the document. So if your plot doesn't look exactly like this or sampled some other numbers, one, it will tell you that your DF4 is probably incorrect, but your graph will not look like this. Okay. Question 5. Use cbind function to combine data frame 4 and data frame 2 into data frame 5. Okay. Binds to data frame 4 and data frame 2. Data frame 4 not found. Oh, I did not run this line. It and see how that goes. Okay. Certainly. What would you like to see?
I don't know what
We're on the last question, so after this I can just come check.
okay.
Yeah. So question 6, use data.frame to combine data frame 4 with data frame 2. So we can actually just like stick them together like this. Even though we're used to data.frame, like taking columns like this as its components in order to create a data frame, you can also do this. So let's knit that. Okay, so that's all of the like calculations that we're gonna have to do for this homework. Keep in mind you will have to on your own answer the question sections that go along with each section. But that's it from me for the recording. Thank you all who came through to the Zoom. I'm going to stop recording now.